In this module, we are going to discuss about sample size estimation. In other words, what should be the sample size required for the study? There are two things we need to consider before we venture out to discuss about sample size. One is called confidence level. Now, sampling is an estimation we are doing about the characteristics or parameters of the population. So, we need to be stating how confident we are that this is the true representation of the population. So, here we have something called as confidence level, which is usually alpha level of significance. So I have, like usually we say 95% of the 95% of confidence is what most of the research is being carried out with 95% confidence. So the chances of making an error is 1 minus 95, it is 5% error, which is tolerable. And the second one is the level of precision. How precise is the sample parameter and the population parameter? What is the permissibility of error? Usually, here also we keep it between 3 to 5%. So the level of precision and the confidence level are the two parameters which we use in estimating the sample size. The sample size is estimated with the formula n0 equal to z square pq by e. Now, in this, z value corresponds to the statistical value when the level of significance equal to 5% from the normal distribution. So, the z value corresponding to 5% level of significance would correspond to 1.96. So, z value is usually 1.96 unless the level of significance increases. So usually 95% is the standard acceptable level. So Z value usually is 1.96. So what matters here is P and Q. If you remember earlier, we had discussed about population proportion incidence. That means, suppose if I am studying a particular characteristics, what is the proportion of incidence which can occur in the population? Take for instance, I am studying the couples who have divorced in a particular population. From previous studies elsewhere, I know around 30 to 40% of the married couples go through a divorce proceedings. So in this case, P would be 40 and Q would be 1 minus 40, that is 60%. So P would be zero point 0.4 and Q would be 0.6. So in case if you don't know the population proportion, it is a good practice to keep P equal to 50% and Q equal to 50% so that the sample size would be the maximum. And E is the level of precision. In this case, usually E is around 3 to 5%. When you use this formula, you get a sample size of around 385. So if you look at the formula, the formula only calculates the sample size based on level of precision, the proportion incidence, and the confidence level. However, here there is no population parameters which are being discussed. So a population could be 5,000, but still you are drawing here 385. The population could be 1,000 also, but still you are drawing a sample size of 385. So in order to bring in a population in computation of sample size, we use another method called as Cochrane's uh, population correction. So here N, the capital big N is the population and N0 is the initial sample size which we have estimated. In this case, N0 was 385 in the previous previous N0 what we calculated, and N in this case we are keeping as 2000. That is the population we are saying the population out of 2000, how much sample I should draw. And when I solve the problem by considering the population value, I get a sample size of 323. So out of 2000, I can draw 323 elements from 2000 sample size, or from 2000 people. I can send the questionnaire. I need a sample size of around 323. Suppose if you are carrying out a survey and you are sending only 323 questionnaire, there are high possibility that only out of 100, out of 323, maybe some people may not respond. So we need to send over more than 323 so that we can get a sample size of around 323 for doing our analysis. And this is based on the response rate. Now, various studies have suggested, like suppose if you are using a face-to-face, if you are giving the questionnaire, then the high chances that people will complete the survey. If you are sending it by post, the response rate may come down. So response rate is one of the factors which you want to consider, especially when you are designing a survey. So at that time, take for instance, I am making a hypothetical choice that only 70% of the people will respond to the survey. So I divide the N3 by 70%. So altogether around 461 questionnaires I will send to different respondents with the hope that I will get a response rate of around 323. We can also estimate the sample size based on standard tables like these authors like Yamane or any statistical textbooks you can refer. And there are standard classical tables by which you can estimate the sample size. In this case, suppose if the population is around 2000 and the level of precision what you want is around 5%, then you can get a rough sample size of around 333. Similarly, without doing any computations or calculations, you can just calculate based on these tables what would be the estimated sample size. Similarly, there are online calculators available. You can just Google and this would be available to you very easily, by which you can, without computation, you would be able to calculate the sample size. While calculating the sample size, there is also one factor we need to keep in mind, that is called type 1 and type 2 error. What is a type 1 error? Type 1 error is a false positive. Take for instance, since we said sampling is an estimation of the population, so there is a high chance that we can make an error. So if in the population, that is on the top, you can say, in the population, there is no difference. Like in this case, this man is not pregnant. So similarly, in the population, there is no difference. So that man is not pregnant. But if your inference is that this man is not pregnant, then you have not made any error. That means you are quite accurate. In this case, the man was not pregnant. In the population also, like there was no difference, and you have found there is no difference, that you correct your test found that there is no pregnancy. So at that time, you are accurately predicted the same. In case if the test predicts that the man is pregnant, like in this case, so there was no difference. However, the test shows there is a difference. That means this is a false positive. That means usually, if you hypothetically also, a man cannot get pregnant. So at that time, you have made an error, alpha. And this alpha is the level of significance, we say 5%. And usually, only 5% chances is there that you can make an error when there is no difference. So this is called as false positive. So 95% of the time, your test or your sample will properly predict. And only 5% of the chance there could be a chance of when there is no difference, a difference to be shown. But there exists also another criteria. When exactly there is a difference, what is the probability that the test could have two possibilities? That when there is a difference, like in this case, this woman is pregnant, so there is a difference, and your test shows that there is a difference, that this woman is pregnant. So this is called as power of a test. That means the power to show difference when there is a difference. So this is called as power of a test, 1 minus beta. And when there is a difference and it shows that there is no difference, like in this case the woman is pregnant but the test shows that you are not pregnant, at that time this is called as type 2 error. This is called as false negative. When there is a difference, it shows negative, that means false negative. And this type 1 error, that is false positive and false negative, are inversely related to each other. That means when type 1 increases, type 2 decreases, and so on. So we need to keep it in balance. So usually in when you are designing a sample size, power is also to be considered in addition to the level of confidence or level of significance, which we have used in estimating the sample size. So usually estimating sample size, we use alpha, the level of significance. However, when you are testing difference between groups or other statistical tests like regression and so on, at that time the power has also to be considered. Usually the power of test should be around 80%. That means 80% of the time it should detect difference when there is no difference. 80% of the time it should detect difference when there is a difference, and there is a 20% error is acceptable. This is quite important when we are studying the differences between groups. Take for instance, you have a sample size of around 40 and you are differentiating the group difference of around 0.2. There is only if at all you use a sample size of around 40, then you have here only 14% chance of detecting a difference when there is a difference. And this is a very low chance. So at that time, what you have to do is increase the sample size if the difference what you are detecting is very small. If the difference what you are detecting is 0.5, then you can see a sample of around 60 would suffice as regards to understanding the power of around 80 and above. So this is a very important fact to keep in mind, especially when you are designing surveys or doing an experiment wherein you are identifying group differences. We need to ask ourselves what is the sample size and what is the power of the test, so that we can make a conclusion when there is a difference, what is the probability that a difference could be detected. There are various authors who have also looked at sample size, and authors like in this they have given some heuristic or thumb rule. Cass and Tinsley recommends that suppose if you are using a questionnaire and the questionnaire is having 10 variables or 10 questions. So at that time, you need minimum 10 response per variable. That means if it is 10 variables, then 10 multiplied by 10 is equal to around 100 responses is the minimum requirement. If the number of questions are 30, then 30 multiplied by 10, around 300 responses are required minimum to carry out a good statistical test. Some statistic authors like Hare, Anderson, who suggest that it is not 10, around 20 responses are required. So that means if 10 10 variables are there or 10 questions are there, then 10 multiplied by 20, around 200 responses are required. Similarly, other authors have also given a preference of minimum 5 to maximum 20. However, the best possible uh, advice is that if a sample size is above 300, then Tabachik and Fidel says that most of the statistical tests, like whether it's a regression or structural equation modeling, can be carried out. However, sample size less than 300 should be carefully selected based on the number of the variables which are there or number of questions which are there in the questionnaire. This brings us end to this module.